Last time we did 1.4, but I only did the introduction on 1.4, right? Do you guys look at the note? What did I teach you guys? We learned about what's the inverse, right? Inverse. So we learned about inverse. Well, I'm going to talk about that at the end. Let's go through the first one was the what? Identity matrix, is that right? Yeah. Okay. Identity matrix basically looks like this. Okay, n means n by n. Okay, this means n by n. And basically the main diagonal has to be 1. Okay, this is 1, 1, and 1, and then the rest are going to be 0. This is all 0 here. Okay. And basically, except the main diagonal is 1, the rest is going to be 0. This is called the identity matrix. So what's the reason we learn about identity matrix? Is to do the division on matrix. Don't worry about it. Yeah, it just there's a crack here, so there's a fail. So the whole reason we learn about identity matrix is to do the division of matrix. Okay, to do division of matrix, because a matrix is not like number. You can just divide it. You cannot divide matrix. You guys follow me here? You cannot. So that's why they have to teach you that. Okay. And then the second, we learn about the inverse matrix. So to learn the inverse matrix also for, we're going to divide matrix. That's for the same reason, okay? So we learn about if you have two matrices multiplied together, okay? And if they equal to, if you flip them, multiply it, okay? And they all give you identity matrix, then they inverse to each other, okay? So then AB inverse each other. Then I think we learned one more thing. What did we learn? Say it again. Method for inverse. Thank you. So the method for inverse we learned about. Very good. If you prepare yourself, okay, you have nothing to be afraid. Your knowledge is your protector. Okay, protects you. Okay. Method for to find inverse. How many different time methods do we learn? Anyone?
2 by 2, 3 by 3.
We learn about for 2 by 2 we use a formula, right? So if you want to find the inverse A, B, C, D, and we find the inverse, you can just use this rotation, okay? It just equal what? 1 over AB minus BC. And then what do we do? Switch these two numbers, right? Did you guys review when you get home? You always should review, okay? Minus C minus B, okay? And so far so good. You guys remember that. Now for 3 by 3, we had to use a technique, okay? We had to go what? A matrix A to I, right? And then what do? We perform Gaussian elimination, okay? Row echelon form, reduce row echelon form to what? I, and then what? A inverse. So that's what we do, okay? Now, because there's some math major students, I'm going to show you guys a proof, a theorem first today. So this is for today's material. This is for recall last time. This theorem tells you that if you have two matrices, okay, A and B, and they are both invertible. Can any student tell me what invertible means? Has an inverse, that's right? That's right. And if they're invertible, that means they have inverse, and most important, they have to be a square matrix. Is that right? Are they square matrices? Only square matrices can be invertible, but not all the square matrices can be invertible. Okay? You guys follow me here? So this tells you this is an n by n. Invertible, okay, means they're n by n. okay? And then they want to tell that AB, they say if, that is if AB are invertible, then when you multiply these matrices together, when you multiply them together, and you find the inverse is also invertible, okay? And not just that, they're invertible, and they equal to B inverse, A inverse. That's what they want to prove. Okay. You guys ready? So I'm going to repeat that, okay? They say if you have two matrices are invertible, means they're square matrices, right? And their product is also invertible. Not just that, when you take the inverse their product, they equal to B inverse and A inverse, they reverse. This is very important. If you're going to go into gaming, this is very, very important, okay? They also do the last action first, and then they work backward. You guys follow me here? So if you want to do a coding about a little boy running and then swing, they do the swing first and then go the run. You guys follow me here? They go backward. The action is going backward. Okay, like this is all purely for students who go into a gaming business, okay? When you do your coding on gaming, which is the big thing right now, okay? So now we're gonna prove that. How do we prove this? So we're gonna prove that they are invertible, okay? So prove. I know that some students major in math, you always need to have an open mind, okay? Do not just stay your mind in one thing. You got to open your mind to different options for yourself. That means if I'm not going to do coding, can I be a math teacher? That's another option, okay? And proof. To prove this, proof AB is invertible, okay? A times B is invertible. So when you prove A times B is invertible, that means, now this means, okay? That means what, okay? So this means that AB times something, now this is just your rough draft, okay? AB times something should equal to BA times that thing. So AB multiply something so equal to something multiply AB, and this is equal to I. So that's your rough draft. It's your goal. Okay. So now we start a real proof. This is just your kind of like your thinking. Okay. This is your thinking. Your goal. Okay. So here's a real proof. You say, given, now this is just your thinking. You should, when you do proof problem, you should always have like a rough draft first, not knowing that what's the given, what I'm gonna go. Okay, now you do the real proof. When you do the real proof, you need to tell people your given information and what you want to prove. Okay, so your given AB are invertible. Given AB invertible, that means, now this means here, okay, A inverse, B inverse exists. So that means that these two exist, okay? You're invertible, so your inverse exists. Make sense to you guys? Okay, now, answer yourself this question, okay? Then, okay, AB times what? Okay, will equal to I. Can you tell me what I fill in there? If these two are exist, so you can use them, okay, because they exist, okay, so you can use them. Okay, AB multiply, who will give you I? Anyone? If you didn't make a mistake, don't worry about it. That's why I'm here to help you, okay? Don't worry about it. What do you think I should put here to make this to be 1? That's right. It's in here, right? You can use a definition, right? If they're invertible, they multiply equal to I, that right? So some students say I could make B inverse here, that right? I could, right? because it exists, that right? So these two become what? I, that right? These two become I. Yes?
Yeah.
Okay? Now, if these two become I, then what should I put in the last one to make this A and that one become I?
A inverse.
A inverse, that's right. Okay? You can see here, this will become, now this will become A inverse. Is that equal to I? The answer is a yes, because AI is equal to A, right? Your identity, is that right? It's like A times 1 is equal to 1. A times 1 equal to 8, that right? So this is A inverse equal to I, okay? Is that equal to I here? The answer is yes, so I is equal to I. So that's your first side of proof. Now you need to flip them, okay? Because it said you need to flip them also, okay? AB times I, and then that same times AB equal to I, okay? Now flip the other side, okay? And we're gonna do, so we do this side already, right? AB times that thing equal to I. Now I'm gonna go that thing times AB equal to I, okay? So what thing times by AB equal to I? What should I put here? Can you tell me, anyone? Look at the what you have earlier, right? So what should I put here? What should I put the last one first? A inverse. Okay, and then B inverse. Is that right? So you can see here that will be I, okay? So B inverse, is that right? And then anything times identity just equal to that thing, that right? That makes sense? Okay, so this becomes B inverse.
Can you say that again for a second?
Huh?
Anything times what?
Anything times 1 is equal to that thing, that right?
Oh, right.
Because I is the inverse for matrix. They just don't use a 1 like that, okay? It's a matrix. So then you can see I is equal to I. So the answer is a yes, okay? So that tells you, so that proof AB inverse in D equal to B inverse, A inverse. Okay? So that's how you prove. So this is a very formal proof for math major student, okay? So you should always get a minor in math if you can. You basically take all the math classes anyway, okay? A minus is just need to take, I think, one more math class when you after you transfer, okay? You basically take all the math. I suggest you take differential equation also if you, that will give you a minus for sure, okay? So a minor in math and a major in computer science or other kind of engineering give you a chance to be a math teacher also, okay, for high school or like that. Any question here? Any question? Okay. So that's how you prove this theorem, okay? The last thing we're gonna do is a few property for inverse, okay? Now, I know the book has a lot of theorems for you guys, so I basically summarize for you so that way you don't have to look at all different theorems, okay? Okay. Definition, a ton of them, okay? So, for inverse, a to the 0 power equal to I, okay? Well, that makes sense, right? Just like we said, any number to the 0 power is equal to 1, except 0 to the 0 power, we're not sure, that right? So that's same thing, okay? And there's a couple theorem after that. It tells you A inverse, okay, to the inverse, it just equal to A. Well, your inverse and inverse pair, you just equal to yourself. That makes sense to you guys? Okay, and the other one is the A inverse to the n power, okay, is equal to the A you power first and then inverse, okay? And you are also equal to a negative n, okay? It comes from after the definition, okay? And a to the n power, now a to the n power, now you cannot just power like that, okay? A to the n power, you know how we do like 2 to the 3 powers equal to 8, that right? But for me, this is same as what? 2 times a 2 times a 2, that right? The same thing, right? Now for matrix, okay, for matrix it's also means a times a times a and times. When you see the 3 dots skip, it means that you skip between, means it's repeating, okay? And n times. Let's see. Okay, yeah, that's all we need for today. We have more, so these are the theorems. I just put it all together so that way you guys don't have to look at all these different numbers for theorem, right? Just put it all into one piece, okay? Now we're going to do some examples. This part is a bit easy now. The example we have is a column number. I did number 6, right? Now we do number 17. Hey? How come this not on? Oh. 17. Can you guys see 17? 17, you see it? Okay. Number 17, they ask you, they said EX has 15 to 18, use the given information to find A, okay? Can you guys see it? Okay. If you cannot, let me know, okay? It said you're given, I couldn't see it to tell the truth. I think it's my own. This is point number 17, okay? They said you are given I plus 2A inverse equal to negative 1, 2, 4, 5. Okay? They want to find A. Is it find A? So you can see the inverse here, right? You want to get rid of the inverse first, okay? How do I get rid of the inverse? You can use this property, okay? So you said, okay, you are given this one, I plus 2A inverse equal to negative 1, 2, 4, 5. That's what you're given, right? Now you're going to take the inverse on both sides of the equation, okay? Use this property right here. You inverse the inverse, okay? So you're going to take the inverse, okay? And then this just become 1, that right? Okay. As a math 3, if you really enjoyed it, it's a pretty good class to understand, okay? 2 by 2 matrix. 2 by 2 matrix, right? So using the property, okay? So 1 over these two, the main diagonal go first, okay? So negative 5 minus 8, okay? And then switch these two number, okay? Switch the main diagonal. Oh. And then inverse these two, okay? And you multiply it together, you add them together, it can become negative what, 13, that right? Negative 13 go inside, okay? Now this is a negative 13 here. And then you multiply to every entry. Now make sure you stop if you you don't understand, you raise your hand, I'm here to help you, okay? Learn your material. Make sure you learn your material. You prepare yourself, okay? You'll be okay. I also asked my student, I said, when you go out to store to buy a product, you want to buy the best product, that right? But when you come to education, you should shop for the best class to take, okay? Don't just go for a class that give you a grade, okay? It means nothing, because when you actually go to work, yesterday when I watched the video, I can really, even those people say that, they said their big mistakes that they didn't use the chance at college to learn the material, to prepare themselves. So you don't want to go out to get a job and then you get laid off. Then you really shatter your self-confidence, okay? You don't want that to happen. You want to keep your job. You guys follow me here? Now they said the civil engineer become very popular major now because the software engineer get laid off. So they start scared. But actually, I don't think it's the main thing. I think the main thing is you're not going to, because you get laid off from this job, doesn't mean you're going to, if you don't change the way you look at things, you go to other job, you're still going to get laid off. You guys follow me here? So the most important, learn your material. Changing your major is not going to help you if you are not changing the way you learn. Okay, you need to change the way you learn. That means every major you pick. Okay, they say civil engineers right now because of the construction things. So most of company not lay off the civil engineer, but they lay off a lot of high tech. So, but I look at it as if you prepare yourself, it doesn't matter where you are. Okay, one girl she said very nicely. She said that this will all come back, but are you prepared for it? He said you're gonna have newer graduate students from just graduate this year, next year, right? The economy is going to come back in a couple of years. He said, are we ready to compete those newer graduates? They learn in school. We learn it online. So she said that she's really scared. So she's thinking about going back to school to learn the computer science again. But I think the best is that you learn it when you're in school at that time. But she said she took it online. So every class is online the last 2 years, that right? So actually, you guys are in a very good position. So make sure you guys don't blow the position away, okay? Don't blow the opportunity away, okay? Right now, when the income is no good, they lay off people, you're supposed to calm down and learn your material, okay? And then, so in 2-3 years, you go out. And those people, even though they had some of the coding experience, but they probably won't get hired because people see them lay off, they like to hire the newer fresh graduate. That's another thing they talk about that too. They said like Google doesn't like to hire people get laid off from other place. They like people that actually just fresh graduated from college. So you guys have very good position right now. So right now in the next 2-3 years, you learn as much as you can. Guys follow me here? Okay, so any question so far? You guys okay? Now this is just for that right? But you need to find A. How do I find A? In your algebra class, what do you do if you need to isolate this number? You subtract whatever, that right? So this time you subtract the matrix I, okay? So you subtract I on both sides. Okay? But what's your I stands for? Say it again. Your I is just a matrix, that right? Okay, what's this matrix? Can any student tell me? It's an I2 or I3 or I4? I2, okay? So it'll be what? 1, 0, 0, 1, that right? Yes? So you subtract I here, but you subtract matrix over there, okay? You guys follow me here? Okay? So now subtract them, what do you get? So when you subtract it, so you get 2A equal to, okay, now this one subtract 1 is equal to A over 13, that right? A over 13, yes? Now if I make a mistake, feel free to correct me, okay? I'm learning just like you guys, okay? This subtract that is just what? 2 over 13, no change? Yes.
Be 18, negative 18.
Thank you. You're right. I go this and that, see? See, I made mistake too, okay? Human. We are human, we make mistakes, so learn to forgive yourself also, okay? This one subtract 0, just that, right? Okay? 1 over 13 subtract 1, negative what? 12 over 13. Okay, so that's what you get for 2 times 8. Then what do I do after that? Maybe you guys can help me. Multiply by 2? 1/2, that's right. Now, measure matrix is very funny. They have their own little rule, okay? Do not put 1/2 here because that is not quite right in technically speaking, okay? You go left times the left, right times the right. You guys follow me here? So you have to put it right here. If you put it right here, I wouldn't say you're wrong, okay? But if you're gonna go into computer science to do your coding, you probably do want to know the correct format to enter, okay? And if you're gonna math teacher, you're definitely gonna be. Okay, so now you're gonna multiply this inside, and your A will equal to 9, that right? Okay, 1 over 13, 2 over 13, negative 6 over 13. Any question here? How do you guys feel about it so far, matrix? It actually pretty abstract. It means that every step has reasoning. So this is good for your critical thinking, okay? Any question? No question, then let's go to another one. Yes?
2 over 13 is supposed to be negative or? Right.
Where? This one?
Yeah.
It's a positive because 4 over 13 subtract 0 is 4 over 13. This one come here, right?
Yeah.
Yeah. This is subtract 0 will still be 4 over 13.
But when you multiply 1 over 13, it was negative, right?
When I multiply this, it was a negative before. When I multiply, it become positive.
Oh,
Any other questions? It's good that you guys pay attention. That's very important. Okay, focus. Focus is a technique that will keeps you live in the present moment. Okay, it's not easy to do, but you can do it. Okay. Any question? Any other question? No, you guys are okay, right? Make sure you check if I make a mistake. Okay. I tell my student that way it keeps them focused in the class. I say if I make a mistake, I'm not going to change it. So make sure tell me ahead. Okay. Number 20. Okay. Number 20. You guys see number 20, right? We're on the same page, okay? It said that the exercise at 19 to 20, compute the following using a given matrix A, okay? I'm going to do C, okay? I'm going to do C. Oh no, actually I'm going to do B. I do B, okay? So we are given A is equal to 2041. Number 20, B, okay? We are given A is equal to 2041. They want to find A to the negative 3. Well, let's look at the property. Which property do we use? This one, that right? Okay, now you can use either one of them. You can power them first and find the inverse, or you can use the inverse and then power them, okay? So either one, okay? So what I did was I actually found the, I actually power first. It's a little bit easy for me to power first because the 0, I like to see the 0. So I go A3 first. A3 equal A times A times A. Multiply them 3 times, okay? So now matrix, you don't power the number. You guys follow me here? A 9 just a real number. Okay? Do not pile the number like that, okay? Now, this is a matrix. You guys follow me here? So then you multiply left to right, okay? Multiply these two matrices first, and after that you multiply these two matrices. And at the same time, okay, I tell you what I get. Just tell you my final answer. It comes out equal to 80281. Okay? Now this is not from power each number, okay? Not from that. So some student probably say that do they have a better way to do this power one? Later on, I can power easier. They do actually. Later on, they teach you to make this to be 0. Then you can just power the main diagonal. But we are not there yet, okay? Not until we get to chapter 4, okay? So right now, that's the way we do the long way, okay? You multiply it, and then you get a matrix. So that's your 8, 3. And then after that, you get the inverse. And you use the 2 by 2, so these two multiply, so it's 8, subtract 0. Okay, switch these two number, okay, so 1, 8, and then negative with this one. It comes out, this is 1 over 8, 0. 1 over 8 times by negative 28. And then it's a 8 over 8.
You can reduce it.
We can reduce it, yes. And 1 over 8, 0, negative by 4. Yeah. Okay? So that's your matrix. Let's look at the answer. Yeah, correct. Huh? Why is it 20? Why is 28? If from multiplication, multiply all three together. You multiply these two first, and then use the final product, multiply that one. That's how you get.
So 4 times 4 is 16.
No. Yeah, but that's not how you multiply.
Oh, okay.
Okay, you are not. Remember, matrix multiplies what? That product, row, that's a column, like that, okay? Again, you cannot think about like how you do the algebra multiplication. I did mention that real numbers are real number, matrix and matrix, okay? Like, do not use a matrix as a real number. They don't share a lot of property. Actually, most of them they don't share, okay? Remember that? Okay?
Is that the final answer to the question?
Yes. That's why that you are taking the class is very important for you, okay? And not easy. That's why if you can do it, you only help a lot of people. The next part I'm going to do is a number 22. Number 22. Okay, right here. They said they compute PA for the given matrix A and the following polynomial. So I'm going to do A, okay? PS equal x minus 2. They're given A is equal 2041. Yeah, given the matrix is a 2041, okay? They want to compute a polynomial from it, okay? They said part A is a px equal to x minus 2. So PA, like, they want to compute PA, you are given PX equal x minus 2, okay? They want to compute PA. So that means let me answer this question. In algebra class, what is x represent? Anyone? The x represent what in the algebra class?
Variable.
A variable, that right? Okay, variable. So this variable could be 1, 2, 3, 4, 5 like that, right? A real number. What is the percent? Can you tell me?
Matrix.
A matrix. So that means that you are putting a matrix in a polynomial. That makes sense to you guys? Okay. So now let me answer this question. Okay, I put an A inside the X now. Oh, maybe I do one more step. Can I put A minus a 2 like that? Can I?
Yes.
I could? This is a matrix, this is a number. Can I do that? Are they friends? No. So what I do? What I do? You need to what? Make this number to be a matrix, that right? How do I do that? By multiply identity, okay? Matrix and real number, they are not friends, they are competitor. That's what I tell my students. They are competing from each other for attention, okay? So a number have to become a matrix. How do you do that? By multiply a identity matrix. You can follow me here? So when you put a number multiply identity matrix, you did not change the problem, okay? Because matrix and matrix, they have to be both are matrix here, okay? So your A become what? 2041 minus the 2 times the I will be what? 2 times what? 1001. Is that right? Yes? You guys follow me here? Right? And then I put the 2 inside here. Okay? Now you can subtract. You cannot subtract for a matrix and a number. Okay? You can only subtract once they become all matrices. And so that becomes what? 2 minus 2 equal what? 0. 0 minus 0 is still 0. 4 minus 0 equal to what? 4. 1 minus 2 equal to what? -1. So that's your final answer. Okay? Any question here? You guys okay? Yeah? Okay. And the last problem will be number 40. Oh, one more property. There's one more property I want to show is, earlier I showed you 3 of them, right? 3 property, right? So, if you have a number multiply matrix, and if you're going to inverse them, okay, and that just equal to now. This one doesn't, you don't need to flip them because this is a number, K is a scalar. K stands for scalar, okay? You can say C or K, usually that's the 2 common number people use. This is equal to K inverse and then A inverse. This one you don't need to flip them because this is not a matrix here, this is just a number, okay? And then if you have an n power, and then Ka n, okay, if it's just an n power here, it's just equal to Kn An, okay? So these are 2 property you can also put it into your file, okay? And the last part I want to do is number 40. Because most of the time you learn linear algebra is meaningful application of it, okay? So students that need to do proof, and I saw you guys love a couple of proof. Number 40 is right here, okay? Right here. Okay. This one. Okay. Okay, you guys have seen it? Okay. They said simplify the expressions assuming A, B, C, D are invertible, okay? So ABCD invertible, so that means the inverse is there. So this one's again is very important for students who go into gaming, okay? I don't know how many students, is there any student here are interested in gaming coding? Nobody? No? Not even one student? One of my students get a job, he get the job as a coding for gaming company in Chicago. It's one of the big company. He told me the name, I forgot. He was the number one in the competition, so that was very good. So you learn your material, you'll be good, okay? I see many my students are actually pretty good in their field. And just learn your material. Don't be afraid of it. Like this particular student I have, he actually took my linear algebra. He took my linear algebra. No, take my 1C twice, and second time he passed it. And the differential equation, he barely passed, but he passed he likes linear algebra, so he passed very good. So he went to UCR for software engineer, and then he get a job at the Chicago gaming. He said he was one of the top. There are 100 people apply for the internship, and he was the number one in the 100 people. That's hard. And she said every day she had to do coding, and then beating me for other 99 people. So that's very good. So if you learn the material, he's not the brightest student I have, but definitely is a hard-working student. So you don't need to be bright, you just need to work hard. That's how I feel it. Eventually, it's your knowledge. It's not because you have quit or something. Eventually, it's your knowledge that you accumulate in school that helps you to keep the job, okay? So sometimes people say, oh yeah, they are A stage student, B student, they get the best. That is of course not really true, I found out. That's my experience from my students. So you guys are not interested in gaming, huh? So nobody want to work for a computer game? Okay. So this basically is all gaming coding sequence, okay? See if you guys remember. What is equal to?
1 conserve
ACE or CA?
Oh.
Remember? Inverse has to be what? The action has to be what?
Backwards.
Second, that's right, they go backward. So these go first. So C inverse is what? C, that right? And then what? A inverse. You guys follow me here? They go backward, okay? It's very, very strange for matrix. That's why I said matrix, your thinking has to be different than algebra, okay? What about this one? There any changing here? No. Any changing? What is it? C what? A inverse. No changing. Okay. And now let's see if you can simplify. How do you simplify? This one gives you nothing, right? But you know this gives you something, isn't it? What is it? I. And then what? I. And then what? I. That right? Now, for math, for matrix, you cannot just say, oh, these are 1, 1, 1, then I'm done. So my answer is C, D. No, they cannot. You cannot do that. So what do? You have to go by critical thinking. When you write the coding, you cannot write it like skipping like that, okay? You have to go with, okay, CI, I know. When I first learned this, I said, this is so tedious, but it is, okay? CI, okay, and then I, okay, and then I, and then T inverse, okay? And then you go this one first, okay? CI, and then become what? CI, D inverse, okay? And then, actually, you know what? Let me check something. We may not even able to skip steps like that. Oh, yeah, we cannot even skip steps like that. We are skipping steps here too. We cannot make this a 2I first, so we have to do it like this way actually. This is CI, and then C inverse. CA inverse. This one can be A and then D inverse. okay? And then now, then you can go Ci equal to C inverse, C A inverse, A D inverse. And that become I. C, now this one you can, actually this one can go together now. This is IC, this can become I, and then D inverse. And then this becomes C, I, D inverse. Then this becomes C, D inverse. That's how you can simplify for matrix. You really cannot say, oh, I, and then it's gone, okay? You have to go with left to right. I know it's very tedious, okay? I remember when I first learned these things, linear algebra is very frustrating class, to tell the truth, because a lot of steps you cannot skip. That's why this class is prepared for students who go into math major. It's also prepared as a student math major for called abstract algebra. That's basically same style. So they had to go, this make it I first, okay? And then after that, make this to be C, C times I equals C, right? And then that, okay? And keep the rest of it. And then this become I. Then now you can, actually I should have even made it to be I, but it's okay. This will become I times C will become C, and then you can make it to be I actually. It was very tedious. It's not like you're doing the real number algebra class, basic algebra class. You could like very quick, right? Because they commute. The reason is because those are real number algebra class, they commute. The real number commute, but matrix does not commute. That's why you go with the sequence. Any question here? So your CD inverse can be replaced by that. Okay? So when you do your coding, you can just code these two inside as the answer that.
Professor Johnson, just
Yes.
a quick question. So when there's an inverse on the outside of the parentheses, that's when we go backwards?
Yeah, because that's when we had the property. Remember we proved that? Okay. So when we prove that theorems. Okay, so that's basically 1.4. Now we're going to go to 1.5 elementary matrix.